Hello, everyone, and thanks for joining us today for today's webinar. We've got a great one for you about digital transformation in pulp and paper. I'd like to introduce today's presenters, Shankar Das and Adam Cooper. I'll let you guys introduce yourselves and take it away.
JP. Good morning, everyone, for this webinar for today. Myself, Shankar Das, joining you from BTG Hyderabad, India. And I am with the industry for last 15 years. I'm currently looking after the digital business for the Indian region. Adam?
Hello, everyone. I'm Adam Cooper, Senior Sales Engineer with the Data Park Group. I've been with Data Park for quite a while now, initially working in the implementations, and now I work with the inside sales team. So hopefully you guys will learn a bit today and we can answer any questions that might come up.
Thank you, Adam. So before we get into the more details of today's session with some kind of demos and understanding, we would like to say a few words about BTG and why we are talking about digital transformations. BTG is a 100-year-old Swedish company focusing majorly on the process optimization, utilizing a lot of our advanced specialty measurements and other consumables which is available in the market. Over the period of time, BTG had made a lot of acquisitions, cutting-edge technologies which is available. And in the recent years, to be precise, in 2016, we acquired a company called Capstone Technologies from US, which is focusing mostly on the software related technology, which is used for the process optimization using data-driven methods. So there are a lot about this data park and the Capstone Technologies, which is coming up in the upcoming slides. And on this journey, BTG has been acquired by Voith, the paper maker, a German-based paper maker, which many of you must be knowing about it. And since then, 2019, we are part of the Voith group. Bit more details into what Capstone and what Data Park is all about. It's as like BTG being a 100-year-old company, Data Park also, it's almost a 30-year-old company, which is focused majorly on data-driven process optimization. And interestingly, it has been developed by a group of chemical engineers who are working for plant and process operations, which was focused majorly on the paper plant itself. And since 1918s, it has been developed, and it's not just a historian point of view, because that was the major drift which this chemical engineers and the founders has been thinking about. And rather than keeping it as a historian point of view, what best we can take it out from the data, creating more insight from the data, creating more decision from the data. That was the thought process behind it. And with this capability, now Data Park is having globally more than 1,000 sites, which is running with the Data Park tool, and focused majorly on the real-time visualization, which we will be talking, and analytics and monitoring point of view. So when we say it is more than 1,000 global installations, out of that 400 and more than 400 installation is purely focused on the pulp and paper industry. And you can see there are a lot of mainstream companies who are using the Data Park as part of their historian plus analytics plus visualization tools. And within our regions also, there are many companies who are utilizing Data Park for their continuous improvement journey. Moving forward, more detail into today's session, what we will be discussing with you people. We will be explaining a bit about what the digitalization looks like in BTG's and the Data Park's terminology, and why it is required and whom it should be looking for. And we will be also explaining you how to understand where are you standing in this whole journey. So that's another important understanding which is required to leap forward in this digitalization journey. And we will be showcasing a few of the technologies which will be helping you and what are the benefit out from that. And there is a demo session which is scheduled for the later part of the presentation, which Adam will be taking. And we would be sharing a lot of success stories with the real case examples. Of course, there will be a question answer session which you can type in your questions as you feel like in the chat box, and we'll be taking that questions at the end of the session. Moving into a digital transformation and digitalization, what it is looking like. So in our industries, there are a lot of data which is getting generated all across. So it is irrespective of the sources. So there are electronic data which can come from a DCS control system, or it can be a scanner, or it can be even from the field instruments. There are a lot of data getting generated. So we cannot limit only to the electronic data. There are the data which is coming from the manual point of view. For example, the laboratory data. Some of the mills having a manual system which is entering the lab data, and some system have a limb system which is entering the data. So there are a lot of data which is being generated on a minute by basis, second by second in the industry. At the same time, it has been collected individually within the DCS, within the lab system, or within the ERP system, something like that, but they are not talking to each other. That's the foundational step what we see in the industry currently. At the same time, we do have a certain amount of site analytics tools, like, okay, you have certain amount of ERP systems like SAP and Oracle systems, and there are historians we see attached with the DCS, which can store a bit amount of data, which is capable of doing basic features of trending and very few analytical features limited to that particular DCS. And there are MES systems also which gathers the data and try to create some kind of output from that. The most important step is connecting this data, because that is another important part when it comes to the digitalization. Connecting the data is another critical step. So we were talking about multiple data sources. So how about each data sources are talking to each other so that they can create a meaningful insight from this data? So that is all about connecting the data. So there should be a system which can collect and connect the data between all these data sources, irrespective of what it is. It's not just limited to the electronic. And once we collect and connect, then it is more important to do the analysis part of the data, because that's the key of getting the benefit out from all these data management tools. So at the same time, it is not just limited to some part of the hierarchy. We'll be talking more about that. But for example, if a technical staff wanted to understand how the data can be utilized, so there are certain tools like a center line. Many people must be aware of that, but still the center line helps the operation team and the technical team to maintain their ongoing process on a very tight framework, so that we will avoid most of the deviations within the process, and batch to batch variation, shift to shift variation, or even grade to grade variation can be very much tightened, and you will be able to do a lot of faster grade changes and without any quality deviation. So these kind of tools will be utilized. At the same time, when it comes to analysis of this data, there are subject matter experts within our organization, and they will be requiring these same data to be used for some other purpose. So for example, they wanted to create a soft sensor tools, or they wanted to do some modeling kind of a principal component analysis or a partial least square analysis, utilizing the same data within the same tool, so that they can take corrective actions. And we have seen the data park is being used very much for doing some kind of mass balance optimization within the company, and do a lot of sheet braid protections, alarming kind of thing. So the idea here is to make it more operationalized. How this data has been collected and utilized and analyzed and make it operationalized is the key. So if we have a system like data park which can do all these functions together within a single click, or a very few setup, which is configuration which has been done, then it would be more easy. The idea is to create all your hierarchy to utilize the data based on their requirement. Why it is required is a question. We have been talking more about, okay, what is data digitalization, but why it is required? Any kind of improvement in the process will be looking for some kind of benefits. So of course it has been connected to the operational efficiency and improved decision making. So how it is possible, like when we talk about in data park world and the BTG world, we talk about digitalization being a profitable digitalization. If we can create a profit in terms of economics, in terms of quality improvement, in terms of operational efficiency, then only it makes a sense to be in competitive in the market. And another critical things which has been used by this data and the data park technology is in the sustainable part of the business. So think about if we can calculate what is the carbon emission which is coming from your power plant or the coal consumption, or even from the chemical industry, chemical usage, and what is the current baseline, and after the improvement, what is the baseline, what you are seeing. If you can get a visibility into this kind of critical sustainability factors, it is going to be really helpful. So data park is always supporting the mill people and the operation people and the management people in a different level to cater into all these features of the requirement. Who will be using data park is a very interesting question, and rather who will be using the data within the process, because the data is been very much generated within the process, and it should be used by all levels of the hierarchy, whether it is the operator cadre or it is the senior management cadre. This should be accessible first of all by all the hierarchies, and at the same time it should be used by all the levels of this hierarchy. It doesn't mean that everyone should be learning a software coding or a configuration method. It should be as simple as you're operating your normal PowerPoint or a Word system. So we are thinking about, okay, developing a normal operator into a process engineer by utilizing all these capabilities and features. They will be easily able to create a lot of value out from this data if they are equipped with certain tools which they can easily utilize. So we have seen senior management looking into all these data coming from the field, and to allocate their assets very efficiently, and to understand where to make an investment in terms of operational efficiency point of view. Something about technical people, which we have already talked about the troubleshooting and understanding how fast we can take a corrective action, or how can we create some kind of predictive controls using statistical process controls and statistical quality control. So these are all the features available. Some usage for the IT and the administration team is more about spreading the data across the enterprise. Beyond the mill side, it should be visible to the corporate peoples also. So the spreading the data into across the enterprise is another strategic usage of this data. So as we say earlier also, it should be usable to everyone in the industry in the speed of the thought. That's the point of having the data in a faster way. Talking more about the transformation journey, we were earlier mentioning where are you currently standing. That understanding will be really required. Ultimately, we will be aiming to be an organization which is mostly a data-driven decision-making organization rather than more of a gut feeling decision-making organization. Of course, the experience matters here. The experience supported with the data will be having a very solid supported troubleshooting or a decision making when the future is to come. So generally what we have seen in the journey is the Indian industry is in between stage 2 and stage 3. We have a certain amount of infrastructure already available within in terms of DCS, QCS, PLCs, which is already available. Now it is the time to gather all these data and to take it into the decision making procedure. So we are quite equipped now, and we can help you getting into the stage 3 and stage 4 as the time is coming up. Some of the technologies driving the digital transformation. So when we are talking about any technologies, whether it is digital or it's a machine or an instrument, it is more about how it is impacting our process. It should be helping us to reduce the cost for sure, and of course it has to have some kind of increasing revenues. There are strategies already available, which is pretty much known to everyone. Like, okay, if you want to increase the revenue, so you will be focusing on increasing the speeds and reducing downtimes and all. At the same time, reducing the variable cost is more about, okay, reducing the energy cost, or optimize your raw material consumption by improving the yield and all. At the same time, there are certain focus on increasing operational efficiencies as well. How it has been attended, like there are certain tactics which can be used to achieve these strategies, like the center lining, as I was mentioning earlier. There are tools like energy monitoring tools, which can help you monitor the energy consumption batch by batch or grade by grade, and take a corrective action accordingly. Asset monitoring, like we have seen a vibration monitoring system, which can be easily attached to the data park solution and create corrective actions and corrective maintenance schedules to that. Predictive models for the subject matter experts and process engineers. We can create a lot of predictive models which is close to digital twins, what we say, and use that tools for corrective actions to that. So in the tool cell application, whatever you are seeing, like the KPI dashboard and the SPCs, SQCs, and profile analysis, the waterfall analysis, which is all an inbuilt feature of data park, and which can be easily used for any of the solutions. When it comes to the results, of course, it has been attached with the results. There are quantified results which we have seen by increasing production between 1 to 6%. There are cases of reducing energies between 0.5% to close to 2%. And interesting factor is like increased human capital efficiency. How do we quantify that? Okay, earlier, without data park kind of solutions, people were taking maybe 4 to 8 hours to do a certain analysis tool. But having these kind of tools, so they will be able to complete within few minutes, like 10-15 minutes, and the remaining time is being used for other efficient usage of that same person. So it is easily been quantified in the current industry era, and this is another advantage which data park kind of tools are giving to the industry. Why it is differentiated, or what is the major difference between data park and normal DCS? Of course, we want to clarify here, data park is not replacing DCS. DCS has its own important functionality within the control rooms, and sometimes it is pretty much limited to the operator's control room. So it can take control actions for sure, but think about if somebody sitting in the corporate office or somebody sitting in a manager's cabin wanted to see what's happening in the process, so that he can help you out taking some troubleshooting and support actions. So in that cases, data park comes into picture. So in case of data park versus DCS, in data park, data can be accessed by anyone anywhere in the plant, even sometimes outside the plant also. And it's more than troubleshooting tools, and it has its own inbuilt analytics. We don't need to rely on any other third-party software to do the analytics part also, and a very variety of KPI dashboards and calculation engines within the data park system. So that's the key differentiation between a DCS. And of course, if you're talking about multiple DCS in a same mill, data park is one central solution which you can connect all the DCS together, and that will be a single source of truth for all your people within the plant. Being said that, I am now handing it over to Adam for showing you some of the demo and take you through more technical details. Over to you, Adam.
Awesome. Thank you, Shankar. So first, we're going to go through some of the steps involved in the blueprint for success. So the first step is going to be to collect the data. You want to make sure that you have instrumentation out there and some sort of means in order to store and have the data on hand. The second step is going to be to transform and optimize the data. So once you get the raw data and you're collecting it in some sort of storage or repository, you want to be able to make sure that the data is able to be accessed optimally and can be transformed into useful and meaningful ways. The third is you want to be able to integrate that data. We want to make sure that you're getting data from multiple sources all within a single tool like Data Park. so that you don't have to go to different silos in order to find the data and be able to use it. The fourth step there is make data easily accessible. So again, having one tool, having the data be fast, having the data be easy to access by multiple levels and multiple users, begins to give us the infrastructure that we need in the next step in order to kind of move forward in our transformation process. So next there is establish decision-making infrastructure. Now that we have all of this data and we've made it accessible, we want to start using it. So we want to set up an infrastructure with our teams, with our personnel in order to start making decisions and be able to utilize the data going forward. And then finally, the last step we have in our blueprint here is to find some quick wins. So yeah, the first step there is we want to start talking about collecting the data. So there's kind of two main tools you might utilize, a time series database versus a data historian. Time series databases are often either open source or can be provided by cloud services like Amazon. So kind of the main difference between the two just has to do with how the data is stored. Data historian is not only going to be able to store the data like a time series database, but also usually includes other tools, possibly like visualization, analytics, and things like that. So a time series database can be useful for kind of getting off the ground or possibly connecting to a visualization tool like Datapark. But a data historian often has more tools for optimizing, utilizing, and then eventually taking advantage of your data and using it in your operations. The second bullet there has to do with sort of where these different tools get stored. So there's cloud versus on-prem. Doesn't make too much of a difference to the Datapark tool. We're able to take advantage of data in both environments. Cloud implementations and servers are often really helpful because they're easy to get set up, and then another company manages them. Yeah, versus on-prem, which can be managed by your team. Next, we have second step, which is to transform and optimize the data. Usually there's kind of two choices that you would have in order to kind of deal with how you're pulling out the data. If you want to have quick trends, then you might have to dumb down the data so that it comes back quicker. This might be minute averages or other compression algorithms in order to kind of speed up the trend. Or if you do want to have high density raw data, that can be really slow to retrieve. And the larger your time frame, the larger your time frame, the slower and slower the data retrieval will take. So it's really important that one of the things that we stress within Datapark and our solution is you want to have rapid access to both your short-term and your long-term high density data. So really you want kind of the best of both worlds. And usually there's a tool like rollup or aggregation that you can use in order to achieve that. So we'll go on to the next slide and we'll take a look at how Datapark does this. So you'll see we have three trends here. We've got our optimized data at the top. Then we've got our raw data retrieval in the middle, which takes a little bit. And then we've got a compressed data stream at the bottom. We're going to go ahead and do some zooms. And what you'll notice is that as we zoom in more and more, that bottom trend loses its resolution. So we'll turn on some dots here just so it's a little easier to see. But you'll notice that the two trends at the top, those are able to show a lot of data. So step 3 here is integrating the data. So again, this is the idea that we want to have all of your data inside of a single software application. So we've talked a little bit about the data historian, but there's other data and systems you might want to have as well. Lab data from the LIMS, scheduling and production information from like MES and ERP, and then other data sources, possibly like shift logs. The goal is to not only have all of your data in one system, like we talked about, so that it's easy to access, but then it's also to have all of your people looking at a single source of truth. You don't have one team or one set of people looking at data in the data historian, and then a second set looking in a second system like the ERP or the LIMS. By having everyone in your organization able to use the same tool to look at the same data, it creates that shared understanding of what's going on in the process. And then you can begin with start doing some reports and some KPIs in order to take advantage of that data. So here's an example of a graphic that is taking in data from multiple sources. We can see up at the top that we've got some statistics in some different areas for yesterday. Then we've got a section for our first production line and a section for our second production line there. We're able to link to other displays like this pre-built trend with some chemical tank information, or we're able to ad hoc just trend one of our tags here and then add another tag to it to begin to look at data from process data like a temperature mixed with a quality tag there. So step 4 in our blueprint, make the data easily accessible. So once we've got it all within a single tool, what you want to do is make sure that the data is inside of a tool like Data Park that is accessible to people in all kind of positions within your organization. So operators are able to access the same data that your engineers see, that your subject matter experts see, and then also that your managers see. Everybody's looking at the same thing and can make decisions off of the same data. So an important consideration for whatever tool you decide is what is the cost structure around licenses? A tool like DataPark has unlimited user licenses as an option, and you want to make sure that it's not going to cost you as more and more people use the tool to get those additional seats or licenses. The 5th step is now starting to build out that infrastructure. So by creating process controls and different displays that everyone is able to use, things like dashboards, which we'll look at, taking advantage of alarms with creating alarm events off of different limits, and then taking that information, rolling it up into reports and the centerline display is a great way to make sure that everyone's looking at the same displays and be able to start making decisions off of the tools that you've built. So to kind of set back to where we were talking about step 5, establish decision-making infrastructure. So like I said, the first segment here is stabilizing. So identifying your different gaps, taking advantage of like root cause analysis, KPIs, and other controls in order to stabilize the process and kind of get that smoothing. Then the second phase there is going to be improving your process. So now that we've done the analysis and we've figured out where some of the issues are, we can begin to improve the process and make different projects and different other things in order to figure out the gaps that are the best to tackle, and then starting to close those through the different projects. And then it's really this third phase that we want to make sure that we stress. If you only do some of these projects and then you kind of let the system go, or maybe only implement administrative control, you'll see with that pink line that all of the gains that you have will slowly start to go away. You want to make sure that you have continuous process control on the system so that you can not only keep the gains that you've made during your improvement process, but also continue to eke out other gains. They may not necessarily be the low-hanging fruit or the easiest, but there are, as you kind of get through the bigger ones, you're going to find that slowly but surely you'll continue to make improvements, and at the very least not lose the good work that you've done. So here's that same video centerline. I'll just re-narrate it real quick. We can see centerline's got a couple different sections to it. It's able to show alarm events that we can link to directly in the display, so we can see how those have done. We're able to trend information for our different groups for the run that we've selected. So we're able to kind of begin to dive into analysis that way. And then finally, if we do want to see how another grade has been run in the past, we can go ahead and show that here. This not only shows us the limits, but also shows us how that new grade has been actually run in the past. So this gives our operators a great way to be able to kind of see what's going to happen next and where we're going. So yeah, here's a video where we're taking advantage of grade-based limits. So we can see that we've got some events down at the bottom. We're going to go ahead and make this a larger span trend. And then what I want to show here is that we can really easily transition to looking at the Pareto chart. So we're able to launch that directly from the trend display in Data Park. And we'll get some bars that represent the different reasons for our alarm events. So in terms of being able to kind of tackle the early wins and make that good improvement, we get a chart here that kind of tells us all of that pretty easily. All right. So our final step within our blueprint here is find quick wins. The idea is that you want to, at the beginning, establish a proof of concept. Hopefully you have something in mind that you're able to apply Data Park in the system to. Maybe not your whole plant, but a specific area or a specific problem. And by implementing this and taking advantage of the infrastructure, you can begin to generate that early return on investment. When people see success in one form or another, that's going to increase your stakeholder buy-in so that you'll get more and more people within your organization who are willing to utilize the tool, put energy into troubleshooting and different solutions and closing those gaps. And then by having that increased buy-in, having some early successes, you'll be able to support your future digital transformation goals. So additional software, additional controls, modernization. It's a step-by-step process, and getting those early wins will help make sure that you have support when you ask for more in the future. So here we'll see an example of a graphic with a downtime. So we'll zoom in on the downtime here. We can see we've got our green events down at the bottom. Those have been acknowledged with like a reason and a comment. And then kind of like we saw before, we're going to go ahead and launch a Pareto chart. So if we're looking to grab those easy wins, this is again is a great tool as you have operators enter information in the alarm events. It's really easy to see kind of what's causing the most amount of issues. So you can take the reason at the top, or the 2 or 3 at the top, start tackling those and get those early wins to get the improvements you're looking for. Another potential for those early wins is energy monitoring. You can see here we've got a graphic that is showing us a few energy sources and the different consumptions across each of those. By putting in a little bit of cost data and some targets, we can add some conditional formatting there, so you can begin to see which of your areas and which of your energy sources are being more expensive or possibly costing you more than you think. This is a great tool for operators to be able to see kind of how their decisions affect the bottom line of your company, assuming that your costing data is available and you're willing to share it out there. And yeah, this is just another good way to put the information out there and begin to try to reduce your energy consumption while still making great product. So a few other kind of things that you might want to consider after those early wins. Here's how you can possibly expand your vision with Data Park, kind of going out there, going forward. So first is beginning to calculate OEE, or overall equipment efficiency, for a given part of your plant. Here we have a graphic with the 3 components: availability, performance, and quality. We can see how each of those are doing, as well as their kind of trends over time to see if there's any issues there. For availability, we can see information with downtime events down at the bottom, and then begin to, like we saw before, put information in against the downtime. And then you have the overall number there in the upper left. So this is something that you and your teams can look at day after day, see what's going on and try to figure out improvements. Next is environmental tracking. So being able to put your different properties out there, different things you want to monitor that you have monitors for, putting that into a graphic like this, adding in the different compliance targets, and then conditional formatting so that you have some levels. You can see here we've got green for in compliance, yellow for alert, which a couple of them have. And then fortunately, this process is not exceeding any of its limits, so we don't have any red, but that's the color that it would take. Then here's kind of another view of environmental tracking. You can see this one's broken up into time chunks, 3-hour, 12-hour chunks for different properties across the plant. Using that same coloring of kind of green, yellow, red, this is a good way to begin and kind of add to your environmental tracking and being able to see how these properties are doing across a day, and then using that information to make sure you stay in compliance. And then lastly, we've got a graphic here that is kind of a dashboard or the dashboard for the enterprise itself. So you can see that we've got a couple different locations for our company listed, a few properties and values listed there with some conditional formatting so we can see how each of the sites are doing. And we also have an overall tab so we can see how the company overall is doing. So this is really great for managers or anyone that wants to kind of compare their plant to another one. You're able to see how each of the locations are doing and able to compare those directly to each other. So what does success look like? We have a few success stories that we want to share with you. Shankar, I was able to hear you, so if you want to talk about quantum paper, feel free to go ahead.
Thank you, Adam. Thank you for detailing through all those technical details and helping us understand how all the application looks like in real scenarios. I just would like to talk about a few of the success stories, and one of the important example is in our region, which is a quantum paper. This is an interesting case with a mill-wide data park implementation with almost 35,000 tags, which is coming from all across the plant, like including the latest DCS systems from various OEMs. At least there are 4 different OEMs which is currently being connected in terms of DCS, and there are QCS systems. So again, 3 different QCS systems is connected, and most importantly, the ERP systems are connected, and the speed, the drive systems which is connected. This is more of an electronic data connected, and most importantly, another challenge with the quantum was to connect the lab data, which is to make it available for the whole organization as soon as the lab test is completed and to be used for the further analysis. So this manual data entries, that is also been connected, and it's a complete mill-wide data park installation, and it has been used for various other purposes. A few of the key features how it is being utilized is the centerline, the process centerlining, irrespective of what the process is, whether it is a paper machine or the pulp mill process. They have created a wonderful centerlining scenario so that they produce more than 30 to 40 grades, and it changes, all the properties changes between grade to grade. So all these grade changes can be more faster, and we can reduce a lot of time between the grade changes. Obviously, it is saving a lot of quality and time and cost in that aspect. At the same time, when we are talking about the pulp mill scenarios, the operators are able to maintain the quality by watching the center lines of their critical operating parameters, and the shift-to-shift variability can be optimized to a certain amount of time. So once they have done with the center lining, the another key usage was towards golden batching. So as I was mentioning, there are multiple grades which has been produced. So there are certain golden runs, maybe 3 months back or 1 year back they have done. So they were able to compare it with that golden run with the current running scenario and take a very quick action so that no much of a deviation which is expected in the process. Another way of utilization is more about troubleshooting. There are cases like in the pulp mill, the jamming situation, the raw material getting jammed in the system. So we were trying to understand what is the root cause behind that. So these tools like Data Park, which can bring a lot of data from multiple sources, were able to identify what is the exact root cause of this issue and to attack that particular problem and resolve it forever. And there are even cases of accounting steam venting, for example, how many times Adam was talking about the Pareto charting. So how many times in a month the steam venting was happening. So the management as well as the process team were having a clear-cut idea how much of time the steam was going out, and then a corrective action has been taken to reduce the steam venting by doing proper troubleshooting mechanisms. And one important thing we wanted to talk about this particular customer, Quantum, is about the change management. People always talk about, okay, we have this beautiful tool, but how it is being utilized in the system. So that's what we were also urging, and the Quantum is a realistic example for that. They were able to create a group within Quantum, so that they have been trained in advanced phases. They are advanced users of Data Park. We call them as power users, and they became the advocate within their organization, so that the next levels of operators and the engineers started understanding from their own people and started spreading within their company itself. So that was more about the Quantum case story. And there are a few more case stories we'll be talking to you. And over to you, Adam, to explain on that.
Thank you. So yeah, our second success story is Domtar. So Domtar was a site, or was a customer that had multiple systems across multiple mills. Some of them were custom, but they weren't talking to each other. So one of the main things that we helped provide them with was a single source of truth, replacing those different systems with Data Park across the board, giving them a common interface to be able to be used for all their mills, and then also just helping them to utilize their data better. Kind of the first step in that was implementing downtime tracking. So by using a common cause or reason tree across all their mills, this allowed us to create corporate level reporting and corporate displays that were all using that same common tree, and be able to kind of standardize the downtime tracking so that people at the corporate level and at different sites were able to use that downtime tracking and kind of start being able to tackle different issues. So this ended up improving their root cause identification or analysis by having this common tree, by having a system that was able to get them their data in a timely manner. They were able to improve reliability, uptime, and efficiency by looking at causes for the process drift. Ultimately for them, this was a quick ROI. They had a 32% in cost to poor quality, and also had 100% project ROI in less than a year. Our third success story is Catalyst Paper, which is now owned by ND Paper. A couple of main things for them was, one, stabilizing the process by applying center lining, specifically grade-based center lining on all of the paper machines at their site. We were able to drive consistency both within the paper machines, but also in their pulp mill and their power and recovery areas. Streamlining these processes allowed for improved efficiency. Engineers were able to adjust recipes and formulas based off of long-term quality data, which meant that they were able to better make the paper going forward. Unifying their monitoring by combining their schedules and their raw material inventory data into one display. So that, again, is that concept of all of your data in a single pane of truth. They were able to utilize centerline displays, which allowed their operators to better manage their current grades, as well as production rates, and kind of improve that. And then finally, just like we've talked about, integrating all of their data into a single source. So being able to see wood delivery, vibration, order management, often through SQL templates, gave them a comprehensive visibility of the whole plant, which allowed them to make better decisions by being able to track kind of how things go throughout the plant and being able to utilize data from kind of every corner. You can see we've got a quote there from their senior process engineer. Data Park has given us the ability to make decisions based off of events as they occur, and in some cases, like including different production schedules, forecast into the future. So with that, we'd like to thank you guys for sitting through everything and welcome any questions that you guys might have.
Yes, thank you, Shankar. Thank you, Adam. That was great. We've got about 10 minutes here for Q&A, and we do have a few questions. So go ahead and ask away. If we don't get to your questions here in the last 10 minutes here, we will follow up with you offline. We can start with one here we got, and either of you can feel free to take this. How can digitization benefit the Indian paper industry, particularly for small scale operations with limited automation, to improve productivity, reduce costs, and stay competitive in the market?
Okay. So I wish to take this question, and first of all, thank you very much for asking this question. So as said, like the digitalization is not limited to the larger scaled industries. There, because if you have seen that um, if we have a minimal infrastructure in terms of a basic data sources, whether it be a PLC system or whether it be a vintage or DCS system, irrespective of the size of the industry, we will be able to help you identifying what is the current loopholes are, like where are we lacking in terms of optimization in certain process areas, or where is an opportunity to improve in our process areas. Let me give an example. So if for example, if there is a deviation in your paper machine, if there is a GSM deviation in your paper machine, obviously the operators are capable to cater that the deviation by their own experiences. So what happens if these operators or the process engineers is being equipped with solutions like Data Park, so that they can clearly see where the problem is coming from? Because certain cases, okay, GSM variation is connected to maybe 1, 2, 3 issues, which has been normal scenarios for years in the past. But there are plenty of cases which we have seen that problems like quality variation is connected with some other issues. Maybe it is connected with a pump oscillation, or it can be connected to some of the vibration in the backend system. So if we clearly identify the problem and permanently solve this problem, then it is going to benefit the industry in terms of cost and economic point of view. So irrespective of what the size or what the grade you produce, you will be able to develop a lot of improvements utilizing this digital solutions. Hope that answers.
Thank you, Shankar. Here's another one. You guys let me know if you want to take this offline. It's a fairly specific question, but you know, can Data Park provide a solution in pulp plants in the lime kiln for reduction of fuel, like furnace oil, and reduction or elimination of ring formation inside the kiln?
Okay. Maybe there is no direct answer to that. Of course, we can create a visibility into these process areas like the pulp mill or the lime kiln areas by collecting the data and try to understand how frequently it has been occurring, and try to make some relationship with some other process variables. Okay, the ring has been formed in the lime kiln on what frequency. You have a database, and we can create some kind of relation with the variables which is associated with the lime kiln, and you will be able to certainly understand for sure what the relationship between multiple variables for sure. The second thing is, if we are looking for reducing the variability and optimizing the process altogether by reducing the fuel, that's the next step. Like we do it in the advanced process control, that we can of course discuss, and we'll come back to you with more questions onto that. Definitely there is a solutions available, And with a more detailed discussion, we will be able to help you out in that for sure.
Great. Here's another one. Is DataPark delivered as a subscription licensing model? What is the model for the India market?
Okay, let me take that question. So DataPark is not in a subscription licensing model. Rather, it is on a perpetual licensing model. So once you buy it, you own it. And on top of that, it is not limited to any number of customers, any number of users specifically, and any number of data sources which can be connected. So there is no limit to the number of users, because as we say, the data needs to be used by everyone in the organization, and there is no limit to the number of data sources also. If you are adding a new DCS next year, so it's not that you will be getting an additional license, rather you can plug it in. Maybe you would be requiring some engineering hours. So it is not on a subscription basis, it's on a perpetual licensing basis.
Great. Here's another question that's fairly specific about a specific unit or operations, but maybe we can address this. So is there a solution provided? And I think the answer is that there's no out-of-the-box solution. DataPark can create a solution for anything here, but is there a solution provided on a pulp plant digester operation with respect to pulp quality, where we have variation of raw material quality?
Adam, do you want to talk about DataPark has been used in the batch processes, like the pulp and the cooking is more of a batch process. So do you want to show some example or say some examples there?
Yeah, we've definitely utilized DataPark for batch digesters as well as continuous digesters like a K-Mir digester. Depends on your operation, but we certainly are able to put the data in and be able to show you data from that area. You probably have logs or some other way to track the raw material quality. So you'd be able to put that in and be able to see how that affects your pulp and eventually your paper further down the process. So yeah, we do have some tools, but we'd want to have a discussion with you to talk about it a little bit more in depth before we kind of dive into any specific solutions.
Great, thanks, Adam. We probably got time for one more question. Here's one coming in here. As we discussed, time series, historian, and relational databases, which one is more suitable for DataPark?
Yeah, DataPark is able to connect to most, if not all of these. So we have our own historian. We're able to connect to relational databases, typically either through queries or something similar. And then we also have the ability to connect to some time series as well. So preferably the data would be in our historian. That's the easiest to access, but we have tools to connect up to multiple different systems. So if you already have a system in place, we just want to take a look at it and most likely can connect to it and pull it into the system.
Great. And that's probably all the time we have for questions right now. It's right up against the end of the hour. So thank you guys again for joining us. And if you have any other questions or if we didn't get to them during the webinar, we'll follow up with you offline. So thank you.
Thanks, everyone.
Thank you, everyone. Bye-bye.